Okay, so in this video we're going to be taking a look at some limit properties, and these properties will ultimately help us solve a good deal of the limit problems that we're going to be taking a look at in future videos. So the first property is the limit as x tends to a for some constant c is equal to c. And here I've drawn the function f of x equals 5. And you can see as x gets closer and closer to 3, f of x, the limit f of x is going to get closer and closer to 5. So, and that would hold regardless of what value x was approaching for this function, because the function's a constant. So regardless of what x is getting closer and closer to, the function's going to get closer and closer to and actually remain at that constant. That's all that this is saying. Okay, the next property is the limit as x tends to a of x is equal to a. To illustrate that, I'm just going to go ahead and draw the function g of x is equal to x, and it continues for negative values of x like that. So let's say we wanted to find the limit as x tended to 2 of x. Well, we approach 2 from the left. You can see f of x approaches 2, approach it from the right, still approaches 2, so that's equal to 2. And because f of x is going to take on the same values as x takes on, whatever x is going to get close to, f of x is going to get close to that same number. And that's all this property here is saying. The next property here is that the limit as x tends to a of some constant c times f of x is equal to that constant times the limit as x tends to a of f of x. And this is, of course, provided that limit as x tends to a of f of x exists. And I'll show you an example of how this property here can be useful. Let's say we wanted to find the limit as x tends to 10 of 2x squared plus 2. Instead of plugging in 10 here, what this property enables you to do is to, well, first you'll see that you can pull out the 2 and say this is 2 times, you can re-express 2x squared plus 2 as 2 times x squared plus 1. And the property says you can pull out the 2 in front of the limit and evaluate the limit as x tends to 10 of x squared plus 1 and just multiply that limit by 2 in order to get the limit as x tends to 10 of 2x squared plus 2. So this is, if you plug in 10 times 10 squared is 10 times 10, that's 100 plus 1. So it's 2 times, you have 2 times 101, that's 202. Okay, the next property is limit as x tends to a of f of x plus g of x equals the limit as x tends to a of f of x plus the limit as x tends to a of g of x. And this is provided, of course, that these limits actually exist. So provided that limit as x tends to a of f of x and limit as x tends to a of g of x exist. Alright, so most textbooks and videos that I've taken a look at show examples that don't really illustrate the power of this property. I'm going to show you one that does. And so the example we're going to be taking a look at is the limit as x tends to 3 of log base 3 of x squared. So when looking at this example, the answer might not jump out at you, and that's okay, because we can do some algebra to make this a little bit clearer. So log base 3 of x squared is the same thing as log base 3 of x times x. And we know, using properties of logarithms, that a logarithm of a product is equivalent to the sum of logarithms. So if you logarithm of log base 3 of, say, m times n is equivalent to the log base 3 of m plus the log base 3 of n. And we can make use of that here. We can just re-express this log base 3 of x times x as the log base 3 of x plus log base 3 of x. And here's where we can use this property here. This is equivalent to limit as x tends to 3 of log base 3 of x plus the limit as x tends to 3 of log base 3 of x. And you can see here that's all we did was we took this sum here, this limit of the sum, and we expressed it as the sum of these two limits. And you can see that that's equivalent to 2 times the limit, because we have that same limit listed twice, so that's 2 times the limit of log base 3 of x. And so we can go ahead and evaluate this limit here. Log base 3 of, as x tends to 3, log base 3 of x is going to tend to log base 3 of 3, which is 1. So this is 2 times 1, and that's 2. So by splitting this logarithm of a product into the sum of logarithms, we were able to use this property here that allowed us to split the limit of a sum into the sum of two limits, and then we evaluated those two limits, which were actually the same limit, so we could multiply by 2. We really only evaluated one limit. We arrived at our answer that way. The next property we're going to be taking a look at is pretty analogous to the one we just looked at. And that's that the limit as x tends to a of f of x minus g of x is equal to the limit as x tends to a of f of x minus the limit as x tends to a of g of x. And this is basically saying that the limit of a difference of two functions is equal to the difference of the limits of those two functions. And the example that'll illustrate this for you is also going to be one that really drives home the power of this property. And it's the limit as x tends to 1 of ln of x over e to the x. So that's the limit as x tends to 1 of the natural logarithm of x over e to the x. The answer might not jump out at you, but we can use some properties of logarithms to arrive at the answer. So from algebra, you'll recognize that the ln of x divided by e to the x is equivalent to the ln of x minus the ln of e to the x and using this property we can split this up into two separate limits. So the limit as x tends to 1 of ln of x minus the limit as x tends to 1 of ln of e to the x. The limit as x tends to 1 of ln of x, well, let's see what happens. As x tends to 1, ln of x is going to approach 0, right? Because if you remember what ln is it's the exponent to which e must be raised for x to become a particular value. So what do you have to raise e to for e to the x to be 1? Well, you have to raise e to the 0, right? And for this limit, we're looking at what happens to ln of e to the x as x tends to 1. Well, this question here is asking you, what do you have to raise ignore that. Well, first we'll look at when x tends to 1, e to the x tends to e. So what this question is asking you is, what do you have to raise e to so that e to the x or e to the y equals e? Well, the answer is 1, right? And this was a two-step process. We first saw that, well, as x approaches 1, e to the x is going to approach e. And then we had to find the ln of e, which is asking, what do you have to raise e to get e? Well, you have to raise it to 1. So this is 0 minus 1, which is -1. So we split this logarithm of a quotient here, which quotient is just the answer to a division problem. We split it up into the difference of two logarithms, and then so we had the limit of the difference of two logarithms, and that by this property we're exploiting here. That's equivalent to the difference of the limits of the two logarithms themselves. And the first was 0, the second was 1. 0 minus 1 is -1. But as an aside, you'll notice that using logarithms helps you for quantities that you can either split up into factors or into a numerator and denominator. If that quantity is hard to work with, but the numerator and denominator are easier to work with, the logarithm allows you to work with just the numerator alone and denominator alone, or as in the previous example we looked at, the factors alone. I want to say the previous example we took a look at was log base 3 of x squared, and you know that's log base 3 of x times x. And if we didn't want to work with x squared, because we could split this up into log base 3 of x plus log base 3 of x, we are able to just work with x alone. And here, because we don't want to work with x divided by e to the x, we can split this up into ln of x minus ln of e to the x. This way we can work with these simpler quantities of x and e to the x by themselves instead of having to work with x divided by e to the x. And that's really the power of logarithms. It allows you to work with simpler quantities by just looking at the numerator or denominator alone, or by looking at individual factors alone. That'll do it for this lesson. In the next lesson, I'm going to go over a few more properties.